Let's talk about another popular sorting algorithm called merge sort. The overall idea is that you split a huge array down as much as possible and then over time build it back up, doing your comparisons and sorting at each step along the way. The general idea of breaking up an array, sorting all the parts of it, and then building it back up again is called divide and conquer. Several efficient sorting algorithms have this principle at their core. Okay, let's see how merge sort works with an example. First, we break up the array into a bunch of arrays with one element each. Now we need to start building it back up again. You may wonder why the one leftover element goes at the beginning and not the end. Don't worry too much about details like that. They'll differ depending on the implementation. However, this step should only have arrays of size 2 and size 1 left. First, we compare these two elements to see which one is smaller. Since 1 is smaller, it'll go first in our new array, and since 3 is bigger, it'll go second. Now we move on and do this with the next pair of arrays. Again, 7 is bigger than 0, so in our new array, we put 0 in the first spot and 7 in the second spot. And now we do this one last time, comparing the last two elements, 10 and 2, and putting them in order in a new array. Great, that was easy enough. Now, the last thing we want to do is keep track of the number of comparisons we did, so we can come back to it when we do our efficiency calculation. Overall, this step took 3 comparisons, each one in green. Okay, we're running out of space, so I'm going to clear everything off except this bottom row and move it on up. Now we're going to combine the first 2 arrays and the last 2 arrays and create an array of 3 and an array of 4. Now these comparisons are a little more complicated. Here we're comparing an array with 1 element to an array with 2 elements. We know that the array on the right is already sorted, so the first element of our new array is either going to come from here or the first element of this array. It looks like 1 is smaller, so that'll be our first element. Now we can move on to the next element in this array and compare it with this one. Since 3 is smaller than 8, we'll put 3 in this box. Now that we're done with this array, we can just take anything that's left in the other one and tack it on the end here. Great, let's move on to building this array. So we're going to start out comparing the first 2 elements of these arrays. That's 0 and 2. Since 0 is less than 2, 0 becomes the first element in our new array. Okay, so now we move on to the next element in this array, which is 7, and compare that to 2. 2 is less than 7, so we put 2 in the new array. We repeat again, checking 7 against 10, and fill them in at the end of the array accordingly. How many comparisons did we do in this step? Well, if you count up all the purple comparisons, that leaves us with 5. Okay, we're almost there. We just need to go through one more round to get our completely sorted array. This is going to start just like it did in the last round. We start off by comparing the first 2 elements of the 2 arrays that we have, so 1 and 0. Since 0 is smaller, it ends up going in this array, and we get rid of it in the old array. We move on, comparing 1 and 2, and end up with 1 being smaller, so 1 fills in this spot. We compare again with 2 and 3, and again with 3 and 7, and again with 8 and 7, and finally we're done. We have our newly sorted array. We need to keep track of the number of comparisons we did in this step, so I'll write 6 comparisons off to the side here.